giving a triangle ABC such that M and N are the midpoints of AB and BC respectively. Show that MN equals half AC. That's. We need to show that this is equal to this. But the first thing we need to do here is to draw the triangle in question. Draw the triangle in question. So, hello guys, let's go into it. So we have solution. We have this. We draw the triangle. First of all, we draw the triangle. And look at it. This is the triangle. Okay, this is A, and this apex is B, and then we have C. Okay, that's what it means. But according to the question, look at this, that the midpoints are M and N. So the midpoint should be here. Midpoint here is M, and then there is N. Okay, we need to show that MN is equal to half AC. That's what we are asked to do. All right, now we have drawn the triangle and we have outlined the midpoints. We have shown all parts of the triangle as expected. Okay, so the next thing to do is to begin to define every parameter of the triangle using midpoints, MN. So let's begin. This MN, we go this way, line MN, okay, is equal to, take it, MB, all right, and then BN, so, or MB. So we have M, line MB, okay, plus BN, good, plus line BN. That's what it means. Remember, this is, we are solving this as a vector, right? Okay, and that's the meaning of this line you're seeing, is a vector. So we have done this, MN is equal to MB and BN, or NB, so to say. Okay, then we're done with that. The next one is, with the go again, we have done this MN for the upper side of the triangle. We're going to do the same for the lower side of the triangle. So this side now, we have line MN is equal to, look at this, MA plus AC, and then CN. I go again. This one, NB, the midpoint, now becomes MA plus AC, and then CN. Let's go. So MA, first of all, we have MA, right? Okay. And then the next one should be plus AC, right? That's from here to there. And then we have plus, what's the next one? CN. CN, so to say. That's it. Okay, so what do we do now? We want to make sure every aspect of the triangle has been taken care of. And this is the first one, MN is equal to NB and then NBN. That's the first one. The second one is MN equal to MA plus AC and then CN. That's the second one. Now the next thing we're going to do is to add this. We add addition, we apply addition. Okay? MN, right? Line MN plus line MN, 2. So we now have 2MN. Alright? Good. Look at it very well. Just look at it closely. We now have 2MN. What does that mean? We are going to combine the first one and then the second one. Let's go. We have 2M, like vector 2MN is equals to, we combine everything now. The first one is MB, right? Plus BN. n, right? That's the first one. We are done with this. Then we add this plus ma, okay, vector ma, and then plus ac, and finally the last one, last not the least, we have cn. Good. So we have now combined the first one and the second one to arrive at this. That's what this 2n means. The next thing we need to do is to collect like terms. Okay? We need to collect like terms. We collect like terms somewhere. We collect like terms. We collect like terms and see what remains. Let's see. If we collect like terms, then what will remain is very simple. We go this way. 2mn, like 2mn is equal to, let's go, mb, we combine with ma because there is m here, and there is m there, right? So they are like. Also, bn, we combine with cn because they are like. Only ac is left alone. So let's go. Now we have mb, right? We combine with ma, so to say, and then plus, what happens next? We have bn, we combine with cn, okay? We have bn, okay, combining with cn. That's what it means. So if we have this, we have 2mn is equal to mb, all right, combined with ma plus ma, all right, plus bn, okay, and then combining with adding with the cn. That's it, and we have only ac standing, only ac standing, because it's not going to combine with anything. So if that is the case, you can see that, let's see, we can now say that MB, line NB plus line MA is equal to 0. That's the first thing. Because we cannot equate it with anything. We cannot equate line NB plus line MA to anything. It's none of this. So it's equal to 0. Then we go again, take BN and CN. Look at it. Line BN plus line CN is also equal to 0 because we cannot equate them with anything. By the left hand side, there is nothing we can equate this to or with. So they are all equal to 0. That's the thing we need to do here. But if you check very well, you see this AC is all alone. It's all alone. And you can see we are gradually coming to this. We then have 2m line mn is equal to, look at this, the one standing alone, AC. Quickly, that's it. So, what happens here is that by the time we divide through, if we divide here with 2, and we come here divide with 2, eventually these two will cancel this. Okay? And finally, we have line mn is equal to half AC, line AC. That's it. So let me write it out clearly where we can see it very well. So with that, we cannot say that we have absolutely come to the point where line NN is equal to half AC, and that is line MN is equal to half AC. So it has been proved. That's it. That is what we have here. And a very clear look, a close observation to this. You will see every step outlined. But if you think there are areas or there are steps you don't understand, no problems, comment it in the comment section. Let's discuss it further from there. I want to sign up now and then prepare for next class.